Good afternoon to everyone. My name is Antonio Pastor. I'm working on the Hexa-X-II project in the activities related with security. And I'm going to give you a brief summary about what we have been doing, what are the trends on analysis we've been doing on as part of the project. The focus is related with the security, privacy, and resilient aspect that we're facing when we're trying to think on how 6G network will be in the next years. Here, the focus has not been never to try to create something new, a different functionality only dedicated for security. But on the contrary, what we want to do is try to address specific threats that are arising with the new technologies, new mechanisms that are enabled that are arising on 6G. For that reason, these specific threats should be addressed with specific mechanisms that help us in protecting, detecting, or mitigating the impact. We are get used to use this terminology of CG, say 6G delta in terms of what is adding if you compare with 5G, 6G that increase the delta on security that should be covered. So to work in that direction, we group the potential threat in what we call threat families and are listed here. We will go over it more in detail, but in general, there are first some topic related with architectural trends, how the architecture are evolving, and how we want to take into account from the point of view of security, privacy, and resilience. Also, the topic related with artificial intelligence is a hot topic. It's a technology that is here to help 6G, but it has also some concerns on security. It should be addressed. Trust infrastructure. Here, what we have to keep in mind is that we are evolving from very limited and controlled environments for the infrastructure to a more close to this cloud continuum, and this requires some kind of awareness on how is my level of trust with the different infrastructure providers, and this is something we need to analyze. And finally, the physical layer that is an option for providing security, and is a new trend on technology that could be leveraged. So what we do is, as I mentioned before, not create differential functionalities. What we do is create security controls that as much as possible will be present to be supporting the enablers that the 6G technology will offer, these safeguard, detectors, or mitigation tools. You can see, or you can name it as enabler for enabler. We have technological enablers that they can call for these security controls to improve the security on their functionalities. It's true that in some cases we can have directly pure enablers dedicated for security. Well, we mentioned this physical layer security or other technologies, and then they can be wrapped as a specific enabler for security, or indeed be also supported over the orchestration and management plans for offering security, privacy, and resiliency in terms of operating security as a service inside of 6G. Going directly for the first one, the architectural trends. Here is basically list the main or the key trends that 6G is facing. First, probably you already all know, that is this network concept, where we have a very independent or dynamic network that should be integrated, probably loosely coupled, to offer global services, personal network, non-terrestrial networks, different transport with different cloud provider, etc. And usually you can only have some kind of limited information exchange, and this could be a problem from the point of view of security. The other key technology is the cloud continuum, where we are assuming that for us it's transparent what is below the infrastructure. You have a uniform access for your application on doing the use of 6G, and you are moving from the far edge or for edge for cloud. It's transparent. But this arises the question on how we can guarantee isolation, the observability, how it is the transitability of the data over these different domains. This is an open topic. And last but not least is the disaggregation, how we are evolving to achieve this disaggregation, especially if we think in RAN, that with the novel generation 5G and now in 6G, we are splitting the RAN as much as possible, creating this disaggregation horizontally and vertically on the application on the stack. So this new disaggregation is nice, very good, but increase the surface attacks because you are opening new APIs, new interfaces between them that should be monitored and protected. In general, for trying to address these issues, our idea is to start with formal specification or formal security proof to analyze these threats. And in this, for example, we have started to create this formal description to execute some experiments on security topics, like using network digital twins. Related to the aspect of this cloud continuum and network, also, the attestation is a critical factor. Using this confidential computing, so you can run your network function without knowing clearly that you have to trust on the infrastructure provider. Confidential computing usually involves remote attestation and trust execution environment like the ones here in the picture. So you can verify that the software that is running is aligned with what you expected, and having cryptographic proof about this. Also about the topology, it is expected that this cloud continuum can generate some lack of visibility on how the traffic is moving over the continuum. And this could be a problem from the point of view security. If you're thinking someone can diverge the traffic, intercept, alterate them. So attestation of the topology, so create protocols and mechanisms that you can put, for example, in the headers of the packets, information that allows the owner of this data to check that the traffic is moving over the specific nodes you have defined is okay. In general, this is not a little, but we also have to think in, for example, how we can converge this image attestation with topology attestation to create more robust security environments. If we move to the second point, that is the trust, here we have a lot of topics that are arise around the security. Not only the model itself, but also how the data it could be manipulated for change the behavior of the AI model. So the pervasive increase of the use of AI, thinking this federated model that you can put pieces of model in different places, increase again the attack surface and could produce some security problems. Also, we need to break these blocks, black box AI or closed box, and try to leverage the explainable AI, because this can help us to identify when algorithms are degrading by some security problems like an attack and so on. And also the privacy implication. Now is a very important point to think of how we can use homomorphic encryption, differential privacy, regularization in order to avoid peaks that can give additional information, privacy information on the data models. This should be analyzed. So one of the lines of working has been use simulation environments. And for that, we can, for example, create attacks on aspects related with privacy, also attack how the data is aggregated to poisoning information that will be used by AI. So these are some approach that we can try to solve in the project. About the trust infrastructure, as I mentioned, we are get used to have these KPI values, SLAs values. So you say, okay, this is a delay, this is the throughput, this is the packet error that I can tolerate in the contract. But today there is no clear process for the trust. How I can, or my indication of reputation of the network we are using. We like to use this trustworthy KPI that has been defined already in Hexa-X project and bring it here to create some mechanisms to evaluate the trust existing between the network domains. Also, cryptography, that is a very valuable tool, should be able to be adapted in order to provide this trust. And we use the terminology of agility, pliability in order to adapt the management process and the different algorithms. Thinking that now we are entering in the world of quantum secure needs on cryptography, and these properties should exist in order to support the functionalities on 6G network. Smart contracts is another technology that can help us precisely to provide through DLTs and smart contract proof and verification of this trust agreement we can have. So basically, this is something we can play with network digital. The latest block is the physical layer. As I mentioned here, we play with things, for example, GCAS and about sensing information that is very valuable in 6G, but we have to keep in mind that this has very strong impact on privacy. So this is something that we need to analyze and simulate again on network digital twin. So just to finalize, what we expect is to offer this through a specific interface, and we are pointing out to use this integration fabric like the Hexa-X-II and adopting these ZSM 14 interfaces that will be pretty soon about the mechanism to interchange this information, request the security controls, and apply them. And that's all from my side.